write the characteristics for the following graphs down here. First one's linear, second one's quadratic. Linear is going to be a little bit less exciting, so there's not as much going on with linear, but that does make it easier. So for example, domain refers to the x values that this graph will reach. Well, the x will always go to the left and right forever. There is no restriction on the x values. So domain will be anything and everything, all real numbers. Same thing with range. Range is y, but there is no restriction on how high or how low this graph can eventually get to. So there is no restriction on the range. It's all real numbers as well. That's why we like linear. As far as end behavior is concerned, I like to look at end behavior as a product of directions on the where it's going. So like for example down here, this end is going left, it's also going down. Now I know that left is negative and down is negative, so this end behavior is approaching negative infinity in both x and y directions. So we can say something as simple as x is approaching negative infinity. I know that f of x is also approaching negative infinity. Then you can look at the end on the right side, and again, keep in mind it's diagonal. It's a product of two different directions. It's a product of a rightward movement and upward movement. This is generally a little bit more number sentence type structure where you're giving it more correct notation. And so the right arrow being positive right and positive up means that we can say x approaches positive infinity, because this arrow means kind of approaching. So x approaches positive, that would be to the right, and f of x, which is y, approaches positive, that would be up. So the first infinity refers to going right, the second infinity refers to going up. Okay, now interval increasing and decreasing. For linear, this part's really simple because if you look at the graph, you read it like a book left to right, it's increasing forever. Okay, don't start in the middle and say, well, it's going down and going up. No, it's increasing forever, left to right like a book. And so, since it's always increasing, we can say that it's increasing from the beginning to the end, from negative infinity to positive infinity. It isn't decreasing. And then the intercepts, we can see them on the graph. The x-intercept would be where it crosses the x-axis. That would be at 2, 0. And the y-intercept where it crosses the y-axis would be at 0, -4. Okay, fairly simple on linear. Quadratic will be a little bit more involved than that, but it's the same concept. You're looking for the exact same things. So on 27 with quadratics, the domain is going to be everything left to right. And so it doesn't stop going left, it doesn't stop going right for anything. There's no restrictions. Domain is everything, all real numbers. Range does have a restriction. You're going to go up forever if you look at the quadratic equation or the quadratic graph down here, but you won't go down forever. You're going to stop at -4. So -4 and up would be your range. Anything from -4 up. Now you can write that a couple different ways. You can write it like that, y is greater than or equal to -4, or you can just write it using interval notation and say anything from -4 to infinity. Okay, end behavior, again, I would suggest just looking at each end and breaking it apart into two separate directions. So that first end here on the left is going left, but it's also going up. Now left is a negative direction and up is a positive direction. So you're actually going to say that x is negative when y is positive. So the left side will be x is negative infinity, or x approaches negative infinity, and f of x approaches positive infinity. And then on the right side, you have a right arrow and an up arrow. It's going right and up. Both of those are positive. So the right side end behavior is going to be x approaches positive when f of x also approaches positive infinity. Okay, your interval increasing and decreasing. Again, read it like a book. So if you read this thing like a book, you've got a turning point right here. Everything on the left side of this graph, like a book, is going down. When you hit that bottom point here, you start going back up again on the other side. So this side over here, I would say is decreasing. This side over here, I would say is increasing. So I go down and then I come back up. The question is, what is the interval? So again, think about a book. The beginning of the book, that'd be negative infinity on a graph. until you get to this turning point, which the turning point is located at x is 3. So everything from negative infinity until you get to 3 is decreasing. That would be the beginning of the book until 3. That interval is decreasing. Once you hit 3, you begin to increase, and you will continue to increase to the end of the book. The end of the book is positive infinity. So anything from 3 to positive infinity, we would say we're increasing. No, because technically at 3 you're neither increasing nor decreasing, so it wouldn't be included in either technically. And then the x-intercepts, we have 2 now because it's quadratic. It crosses at 1, or at 1, 0, and then it crosses at 5, 0. And then the y-intercept, it crosses up here at 0, 5. So that's just kind of point and click.